Once again, I would like to remind you that inverse functions undo each other. And we're going to use this idea when we're trying to verify whether or not two functions are, in fact, inverses of one another. And in order to do this, we use what's called composition functions. Composition functions is when you plug one function into the other function. What that looks like is f of g of x or g of f of x. So this one says we're going to plug g of x function into the f of x function and replace g of x wherever we see x. Or here we plug the f of x function into the g of x function, replacing f of x wherever we see x. That sounds really confusing until you start actually seeing examples, which I'll show you in a moment. That's not the only way we can write composition functions. I do want to point out this is the second form of writing composition functions. No, this does not say fog, okay? I hear so many students calling that. What it is f, and then we have an open circle of g of x. So what that's saying is we're plugging this second function into the first function. So this is equivalent to this. If I wanted to write g of f of x with this notation, it would be g, the open circle, and then f of x, saying we're going to take the f of x function and plug it into the g function. If two functions really are inverses of one another, what's going to happen is we're going to end up with x each time. Let's take a look at part A. We want to verify that x plus 6 is x minus 6. Now in theory, thinking about it, those are opposites, so this should work out. We're going to do composition functions twice. The first time is going to be showing f of g of x. Again, what this means is we're going to take the g of x function, which is x minus 6, and plug it into f of x. So really it looks like this. F of g of x is equivalent to f of x minus 6. Putting an x minus 6 wherever we initially saw the x. So that looks like x minus 6, because I substituted that in for x, plus 6. The 6 cancel, and I do in fact end up with x. Remember, that's what we wanted. Now it has to work in both directions. So we did f of g of x. Now we have to do it a second time, but we have g of f of x, or g of the whole f of x function, which is x plus 6. And we're going to replace the x with the whole function x plus 6. Okay, so really I have x plus 6 minus 6. Once again, you can see we do in fact end up with x. So were they inverses? Yes, they were. We verified it. Part B. Okay, there's a typo here. Here's f of x, here's g of x. We're going to verify it, so I'm going to start off with f of g of x, meaning it's f of the whole g of x function. So I'm going to put a negative 1/3 x minus 3 wherever I see x in the original f function. So I have a negative 3 times, I'm replacing the x with a negative 1/3 x minus 3, and I have that minus 9. Okay, now I need to simplify this. I'm going to distribute this negative 3 here. Negative 3 times a negative 1/3 is a positive 1, so I have a positive 1x. Negative 3 times negative 3 is a positive 9, and I have that minus 9 at the end. They cancel, and I do, in fact, end up with x. So I know that way works. Let's try the other way, g of f of x, which means I have g of the whole f of x function, negative 3x minus 9. This is what I'm replacing the x's with. So what I have here is a negative 1/3 times x, so I'm going to put that negative 3x minus 9 there, minus 3. Clean it up. I need to distribute that negative 1/3. Negative 1/3 times negative 3 is a positive 1x. Negative 9 times a negative 1/3 is a positive 3, because 9 divided by 3 is 3, and then minus 3. So they cancel. I do, in fact, end up with x. So yes, we have verified that they are, in fact, inverses. If they were not, we would not end up with an x here.